Hello guys, this is Info RX. We are the tech experts. If you need tech-related information, subscribe our channel and click the bell button. Follow our social media pages. Okay, let's go to the topic. XFX QuickSilver Radeon RX 7800 XT Magnetic Air Review, a QuickSilver Class Limited Edition. XFX introduced its Radeon RX 7800 XT Magnetic Air graphics card, featuring an innovative design with detachable, magnetically levitating fans. This latest model stands as the fastest in XFX's lineup, combining high performance with unique customization options. Right out of the box, the card is enhanced by the manufacturer to deliver optimal performance, showcasing not only its capability but also its striking appearance. This white edition in the 7800 XT series, this graphics card features a striking all-white design, including the PCB, heatsink, and cables. It has been specially modified at the factory to boost its cooling capabilities, ensuring it runs smoothly and quietly. This results in a slight performance increase of about 3%. Built for stability and efficient cooling, it's ideal for gamers looking for a reliable and powerful gaming experience. Additionally, it's priced competitively at $499, making it an attractive option for those looking to upgrade their setup. The XFX Magnetic Air system offers a hassle-free solution for quickly swapping out fans on a graphics card, eliminating the need for tools or screws. This system utilizes powerful neodymium iron boron Feb magnets, boasting a magnetic strength of 400 Gs, strong enough to support weights up to 1 kilogram. Impressively, these magnets maintain their strength over time, simplifying maintenance and servicing. The fans are designed for efficiency and performance. They feature 11 blades and can operate at speeds up to 3,200 RPM with a maximum airflow capacity of 70.08 cubic feet per minute CFM and an air pressure peak at 4.88 mmAQ. They ensure effective cooling under high performance demands. The cooling system is enhanced by a nickel-plated copper vapor chamber that serves both the GPU and DDR modules. This setup improves heat distribution and efficiency. Additionally, XFX strategically places thermal pads over all crucial components like GDDR, VRM, and the backside of the PCB. This design choice aids in managing heat dissipation effectively. A significant innovation is the use of Honeywell PTM7950 thermal interface material TIM, which extends the period between maintenance needs due to its exceptional longevity and effectiveness. Furthermore, the incorporation of a two-phase vacuum heat transfer system marks a substantial upgrade over traditional cold plate methods, ensuring superior heat transfer capabilities. This advanced cooling technology, crafted from nickel-plated copper, underscores our commitment to providing robust and reliable thermal solutions for high-performance computing. The Radeon 7800 XT graphics card, with a boost frequency of 2430 MHz and a total graphics power (TGP) of 212 watts, is designed to be efficient. This version of the card, which occupies 3 slots in a computer, can operate at slightly higher clock speeds than the standard model. It features two 8-pin power connectors to supply energy. The card comes with 16 GB of memory across a 256-bit interface, running at a speed of 19.5 Gbps, which is impressive for handling complex graphics tasks. It utilizes the full capabilities of its architecture with 60 compute units KISS and 3840 shader processors, resulting in a total board power TBP of 263 watts. This makes the Radeon RX 7800 XT a robust choice for gamers and professionals. Based on the Navi 30 DSCU architecture, the GPU includes advanced components like for memory controller domains MC-DIS. It features 3840 cores, strategically distributed across the 60 KISS to maximize performance. The GPU also includes a significant 64 megabytes of Infinity Cache, which operates at 19.5 GBps. This setup provides an impressive total memory bandwidth of 576 gigabytes per second, enhancing the card's ability to handle data-intensive applications efficiently. This blend of features makes the Radeon 7800 XT a robust option for those requiring very decent graphic processing capabilities. The graphics card presents a sleek, modern white look and operates at an enhanced frequency of 2430 mHz and uses a TGP at 212 watts. This graphics card includes a BIOS switch on its top side, making it easy to switch between modes depending on your needs. In terms of noise level, the card at default is remarkably quiet. This model boasts a memory speed of 19.5 GBps and utilizes a 256-bit memory interface. Additionally, it can handle power well above 300 watts, ensuring cooler operation and increased reliability. Distinguished by its I/O configuration, it is powered by 8-pin connectors. It adheres to AMD's MBA reference model specifications and includes a single HDMI 2.1 connector along with 3 DisplayPort 2.1 ports, a tri-fan. Cooling design maximizes airflow around the backplate, ensuring effective thermal management. By default, the card operates in performance mode, which enhances its performance by 2 to 3% compared to standard reference models. Unlike some newer models, the Radeon RX 7800 XT still uses standard 8-pin PCI connectors instead of transitioning to the newer 1.2 VHPWR port. This feature allows for a wide range of compatibility with existing power supply units. XFX has released the Radeon RX 7800 XT Magnetic Air graphics card, part of the QuickSilver Limited Edition series. This model introduces a untried design featuring detachable, magnetically levitating fans, setting it apart in XFX's product line. The card is pre-optimized by the manufacturer for enhanced performance, designed to appeal to users looking for advanced graphical capabilities combined with innovative aesthetics. The Radeon 7800 XT, with its 16GB to 156-bit memory configuration at 19.5 GBps, is bound to impress. This particular iteration is poised to utilize the complete 60Cu. 3840 shader processors setup of the GPU and boasts a total board power to be P of to 63W. The AMD Radeon RX 7800 XT GPU is built upon the Navi 30 SKU framework and thus chiplets, incorporating for memory controller domains MC DIS. The GPU core boasts 3,840 cores meticulously distributed across 60 compute units to enhance performance. Additionally, the GPU incorporates a substantial 64 megabytes Infinity Cache functioning at an 18 GBps pin speed, yielding a commendable total bandwidth of 576 gigabytes per second. The second Navi 30 variant, aka Radeon RX 7700 XT, sees a friendly 54Cu 3456 shader processor configuration, complemented by 12GB memory on a 192-bit bus running at an effective 18 GBps data rate. This points towards a Navi 30 iteration, with one of the 4 MC DIS disabled, resulting in 48 megabytes of Infinity Cache. The core setup of the RX 7700 XT is anticipated to encompass approximately 54 compute units, housing a total of 3,456 stream processors. You will not see the new 12-pin power connector header introduced by NVIDIA. The cards will hold 8-pin headers. Configuration depends on AIC. AIB choices, as partner cards are free to choose to use whatever they deem applicable. Some remarks: first, the card has a dual BIOS, however currently is just that. There are no differences in between the two BIOS modes. Both the Radeon RX 7700 XT and 7800 XT offer diverse connectivity options featuring 3x DisplayPort to 0.1 and 1x HDMI 2.1 outputs. With AMD's Radeon's display engine, the card supports DisplayPort 2.1, enabling frame rates as high as 480 Hz in 4000 and 165 Hz in 8K. The standout feature of this graphics card is the MagAir system, which employs magnetically levitating fans for a tool-less and swift replacement process. These fans are secured with neodymium iron boron Feb magnets, which are known for their high magnetic strength of 400 Gs and the ability to hold up to 1 kilogram. The durability of these magnets reduces the need for frequent maintenance. The fans themselves are designed to maximize airflow and cooling efficiency. They include 11 blades and are capable of speeds up to 3,200 RPM. The fan's design allows them to move air up to 70.08 cubic feet per minute CFM and achieve a maximum air pressure of 4.88 mmHg, ensuring adequate cooling during intensive operations. Enhancing the cooling capabilities further, the graphics card includes a nickel-plated copper vapor chamber that efficiently distributes heat across both the GPU and DDR modules. XFX has also incorporated thermal pads strategically placed over critical components such as GDDR, VRM, and the rear side of the PCB to enhance heat dissipation. The Radeon RX 7800 XT is equipped with 16 GB 256-bit dedicated memory suitable for contemporary games and graphic-heavy applications. We have reviewed a reference model from AMD. Central to the Radeon RX 7800 XT is the RDNA 3 GPU architecture from AMD, which offers enhanced performance, power, efficiency, and features relative to earlier versions. The cooler for the Radeon RX 7800 XT boasts a triple fan design with 13 blades on each fan and an illuminated XFX logo on the top. The card has an heatsink running through it, and there is a tiny opening on the backplate that the last fan may use to disperse hot air externally. It weighs in at close to 1 kilogram and is 33.7 x 13.2 x 5.9 centimeters sized. In terms of power delivery, the XFX Radeon RX 7800 XT has a dual 8-pin connector layout. A notable technological advancement in this model is the use of Honeywell PTM7950 thermal interface material, TIM. This material is recognized for its longevity and effectiveness, extending the duration between required maintenance. Additionally, the graphics card features a two-phase vacuum heat transfer system, an improvement over traditional cold plate methods, which significantly enhances heat transfer capabilities. This advanced thermal management system not only prolongs the hardware's durability, but also ensures that the Radeon RX 7901 XT MagAir operates at optimal temperatures, thereby maintaining high performance under challenging conditions. Another difference between the XFX and AMD's reference Radeon RX 7900 XTX and Radeon RX 7900 XT graphics cards is the lack of a USB Type-C connector, which most gamers will not need anyway. This model card has a dual BIOS. The default BIOS that comes with the card has a reference setup. Dual BIOS setting right offers it to 12 West factory. Default setting game CLK, up to 2124 MHz boost CLK, up to 2430 MHz note. Right BIOS is the next to IO Shield. Light accents enhance the card's appearance. Hardly any LEDs are active on the card aside from an XFX logo. The product is aimed at a $499 SRP. Radeon RX 7800 XT specifications. There are several differences between RDNA 2 and RDNA 3. However, the RX 7000 series has 20% more compute units CS and doubles the number of FP3 to 32-bit floating point computing functionality per CU. AMD still employs 60 for streaming processors SPS per CU. However, that amount is more like double in many respects. Each GPU holds a single GCD chiplet graphics compute die and up to 6 MCD chiplets memory cache die. The XTX has a fully enabled GCD and 6 MC DIS. In contrast, the 7900 XT has a partially enabled GCD with 80 for CUS and 5 MC DIS. The 6th MCD slot will remain occupied, either with a dummy piece of silicon or a non-functional MCD non-functional because it is fused off, though it may or may not be defective. Transistor counts have increased significantly compared to the previous generation RX 6000 series with 58 billion total transistors compared to only 26.8 billion on Navi 21. Theoretical computation has increased by up to 159% compared to the RX 6950 XT, with 61.4 teraflops on the XTX card and 51.6 teraflops on the XT variant. Architecture: when it comes to the graphics processing unit, things start to heat up. Even though the 58 billion transistors in AMD's new GPUs are not all in one spot, the company claims they are the fastest ever built. AMD quickly points out that these are the first gaming GPUs to use a chiplet architecture. Based on the company's experience developing chiplet-based Ryzen central processing units, AMD added two new key components to the RDNA 3 GPU: a GPU chiplet GCD and memory chiplets MCD. 6 MC DIS will surround this GCD on both cards. These are substantially smaller chips than the GCD, measuring 37 square millimeters. These are constructed on TSMC's 6 nanometers manufacturing node. Each of them has a 64-bit memory controller as well as a second-generation Infinity cache. All 6 of these MC DIS will work on the RX 7900 XTX. On the RX 7900 XT, only 5 of them will function. The 6th chip will remain, but AMD claims it is for manufacturing reasons, structural stability, which I assume means it is for the packaging process and possibly for optimal cooling. That means the 7900 XTX should have 96 megabytes of Infinity cache, whereas the 7900 XT has 80 megabytes. The Navi 31 GPU has made numerous appearances in leaks and rumors over the past year. This GPU is made in 5 nanometers and has up to 12,288 shader processors and 96 megabytes of Infinity cache for the Radeon RX 7900 XTX. This graphics processor is stated to handle a 384-bit memory bus and capacities of up to 24 gigabytes of GDDR6 20GBPs. AMD now touts multiple clock domains for the XTX, that's 2.3 GHz for the shader clock frequency and 2.5 GHz for the front-end clock speed. That helps them save energy. RDNA 3 employs split clocks in the shader and front-end. According to the company's developers, the front-end was limiting gaming performance more than the shaders themselves. In RDNA 3, splitting the shader clock and the front-end clock allows for a faster front-end frequency of up to 2.5 GHz and a slower shader rate of 2.3 GHz. According to AMD, this amounts to a 15% frequency increase while preserving a 25% power savings. The company will launch its high-end series based on the Navi 31 GPU, with Navi 32 and 33 following later. AMD's next-generation RDNA 3 GPUs will use WGP workgroup processors instead of CU compute units. Each WGP will have to CS, but each CU will have for SIMD 3 to clusters instead of just 2 on each CU. In RDNA 2, there are also AI units present. Though we lack full information, these seem to be tensor equivalents. The RDNA 3 architecture of the AMD Navi 31 GPU has one GCD graphics compute die based on dual SIMD units, effectively doubling up shader count. The RX 7900 XTX features 96 CUS each. With 64 dual-issue processors, these processors can process 2 instructions down each data path, resulting in twice the instruction issue rate of RDNA 2. It is not 2 times faster. Instructions can just be executed twice as quickly. Power consumption: we have transitioned to utilizing a power interposer for enhanced power consumption analysis. This combination of hardware and software delivers an accurate testing environment that focuses on the 12 volts rails and the PCIe slot, effectively isolating power consumption from external influences such as socket outlet measurements. Our updated approach enables us to deliver more accurate data, including idle power consumption, while continuing to showcase average, typical, and peak power consumption based on gaming loads. The decision to implement a power interposer stems from the inconsistencies in reporting from NVIDIA and AMD. While NVIDIA typically reports both chip and board power via API, AMD's reported values tend to fall somewhere between chip-only and full board power. This has been confirmed through third-party interposer testing methods such as PCAT and other similar techniques, relying solely on API reporting software like GPU-Z or Winfo64 does not provide the level of accuracy needed for proper chip or board comparison. Our enhanced setup, which polls every 100 milliseconds, enables us to objectively measure peak and typical energy consumption. Here is our power supply recommendation: Radeon RX 7600 XT. On your average system, we recommend a 600-watt power supply unit. Radeon RX 7700 XT. On your average system, we recommend a 650-watt power supply unit. Radeon RX 7800 XT. On your average system, we recommend a 700-watt power supply unit. Radeon RX 7900 GRE. On your average system, we recommend a 700-watt power supply unit. Radeon RX 7900 XT. On your average system, we recommend a 700 to 750-watt power supply unit. Radeon RX 7900 XTX. On your average system, we recommend a 750-watt power supply unit. Graphics card temperatures: to begin, we will focus on idle temperatures of desktop GPUs as reported by thermal sensors in software. Generally, temperatures below 50 degrees Celsius are acceptable, while temperatures below 40 degrees Celsius are commendable. To provide additional context, we have included temperature data from several other GPUs we recently tested in a chart. However, when it comes to gaming, the temperature of the GPU can significantly increase. To measure the highest temperature reached during intense gaming sessions, we conducted stress tests while monitoring the GPU temperature as reported by the thermal sensor. It's worth noting that all tests were conducted in a room with a temperature of 20 to 21 degrees Celsius, and we used a GPU stress loop to achieve peak performance. Long-duration stress temperature and GPU throttling clock. Always, before beginning benchmarking, the card is preheated. We monitor the dynamic clock, the GPU throttle, once the GPU has warmed up. This is around approximately 2400 MHz, and we see this during the repeated warm-up phase of at least 15 minutes of GPU gaming stress. We do this before every evaluation because a cold card could perform better in the first few seconds of a benchmark. Power consumption: we have transitioned to utilizing a power interposer for enhanced power consumption analysis. This combination of hardware and software delivers an accurate testing environment that focuses on the 12 volts rails and the PCIe slot, effectively isolating power consumption from external influences such as socket outlet measurements. Our updated approach enables us to deliver more accurate data, including idle power consumption, while continuing to showcase average, typical, and peak power consumption based on gaming loads. The decision to implement a power interposer stems from the inconsistencies in reporting from NVIDIA and AMD. While NVIDIA typically reports both chip and board power via API, AMD's reported values tend to fall somewhere between chip-only and full board power. This has been confirmed through third-party interposer testing methods such as PCAT and other similar techniques, relying solely on API reporting software like GPU-Z or Winfo64 does not provide the level of accuracy needed for proper chip or board comparison. Our enhanced setup, which polls every 100 milliseconds, enables us to objectively measure peak and typical energy consumption. Here is our power supply recommendation: Radeon RX 7600 XT. On your average system, we recommend a 600-watt power supply unit. Radeon RX 7700 XT. On your average system, we recommend a 650-watt power supply unit. Radeon RX 7800 XT. On your average system, we recommend a 700-watt power supply unit. Radeon RX 7900 GRE. On your average system, we recommend a 700-watt power supply unit. Radeon RX 7900 XT. On your average system, we recommend a 700 to 750-watt power supply unit. Radeon RX 7900 XTX. On your average system, we recommend a 750-watt power supply unit. Graphics card temperatures. To begin, we will focus on idle temperatures of desktop GPUs as reported by thermal sensors in software. Generally, temperatures below 50 degrees Celsius are acceptable, while temperatures below 40 degrees Celsius are commendable. To provide additional context, we have included temperature data from several other GPUs we recently tested in a chart. However, when it comes to gaming, the temperature of the GPU can significantly increase. To measure the highest temperature reached during intense gaming sessions, we conducted stress tests while monitoring the GPU temperature as reported by the thermal sensor. It's worth noting that all tests were conducted in a room with a temperature of 20 to 21 degrees Celsius, and we used a GPU stress loop to achieve peak performance. Long-duration stress temperature and GPU throttling clock. Always, before beginning benchmarking, the card is preheated. We monitor the dynamic clock, the GPU throttle, once the GPU has warmed up. This is around approximately 2400 MHz, and we see this during the repeated warm-up phase of at least 15 minutes of GPU gaming stress. We do this before every evaluation because a cold card could perform better in the first few seconds of a benchmark. Graphics card thermal imaging measurements FLIR. In order to obtain a more precise visualization of heat emissions from tested products or components, thermal imaging hardware such as a FLIR camera are utilized. The term FLIR is short for forward-looking infrared and refers to a brand of thermal imaging camera. The infrared light emitted by all objects within the field of view is focused through a specialized lens and scanned by a phased array of infrared detector elements. The resulting temperature pattern, known as a thermogram, is incredibly detailed and obtained in less than 1/30th of a second. The thermogram is created by several thousand points and then translated into electric impulses, which are processed by a dedicated chip on a circuit board. The final display shows various colors corresponding to the intensity of the infrared heat and indicates hotspots on the card or PCB. By analyzing the heat distribution throughout a product, temperature bleeds can be identified. To enhance analysis, we have made slight modifications to the thermal image by adding a card and heat map overlay. Graphics card acoustic levels. When graphics cards produce a lot of heat, usually that heat needs to be transported away from the hot core as fast as possible. Often you'll see massive active fan solutions that can indeed get rid of the heat, yet all the fans these days make the PC a noisy son of a gun. Do remember that the test we do is extremely subjective. We bought a certified dBA meter and will start measuring how many dBA originate from the PC. Why is this subjective, you ask? Well, there is always noise in the background from the streets, from the HDD, PSU fan, etc., so this is by a mile or two. An imprecise measurement you could only achieve objective. Measurement in a sound test chamber, the human hearing system has different sensitivities at different frequencies. This means that the perception of noise is not at all equal at every frequency. Noise with significant measured levels in dB at high or low frequencies will not be as annoying as it would be when its energy is concentrated in the middle frequencies. In other words, the measured noise levels in dB will not reflect the actual human perception of the loudness of the noise. That's why we measure the dBA level. A specific circuit is added to the sound level meter to correct its reading in regard to this concept. This reading is the noise level in dBA. The letter A is added to indicate the correction that was made in the measurement. Frequencies below 1 kHz and above 6 kHz are attenuated, whereas frequencies between 1 kHz and 6 kHz are amplified by the awaiting. 3 mark times SPI is a DirectX 12 benchmark test, available as DLC right now on Steam and to all Windows editions of 3DMARK. With its pure DirectX 12 engine, built from the ground up to support new features like asynchronous compute, explicit multi-adapter, and multi-threading, SPI is the ideal benchmark for testing the DirectX 12 performance of the latest graphics cards. Developed with input from AMD, Intel, Microsoft, NVIDIA, and the other members of the FutureMark benchmark development program, SPI shows the exciting potential of low-level, low-overhead APIs like DirectX 12. Mind you that we list the GPU score. Thanks for watching this video. For more information, touch with us, comment your opinions about this video.